we know that the CPU is one of the most important components in the computer. So it should follow that if we can improve the way that the CPU can get through a program, then our computer should improve. It should go faster, it should respond better, it should just be a better computer if we can improve CPU performance. And there's three key ways we look to do that. I'm going to talk about all three. The first thing that we can do is we can improve a CPU's clock speed. And when I say improve, I really sort of mean buy a new CPU which has got a faster clock speed. Now clock speed is measured in hertz, okay? That's the it's abbreviated as HZ there, and hertz is how many fetch, decode, execute cycles you can get through in a second. So take a look at the animation on the right there. If I've got a processor which has got 1 hertz and I'm getting through, let's say we're going to use 4 instructions. Okay, so 4 instructions, 1 hertz, 4 instructions. It can process 1 in a second. How long do you think that should take? Well, of course, it takes what? It takes 4 seconds. Makes sense, doesn't it? So we've got 4 instructions, 1 instruction a second, so it takes 4 seconds. However, if I get a CPU which has got 2 hertz, I'm still processing the same amount of instructions here, so 4 instructions, but it's 2 hertz. Have a look at the animation right now. It takes 2 seconds, okay, because I can process them twice as fast. So I'm improving the performance of my CPU by increasing the amount of times I can go around the fetch, decode, execute cycle in a second. And so modern processors now are measured in gigahertz. So you're talking about billions of cycles a second. And that can be sometimes across multiple cores, which is what we're going to talk about next. So the other thing that we can have a look at is the number of cores which are on the processor. And what I want you to imagine is that I've got a CPU which is at 1 hertz, so it could only perform sort of 1 cycle in a second. However, I've got 2 cycles going on at the same time. Okay, so I've got 2 different cores which are doing 2 cycles at the same time. And if I'm still doing my 4 instructions up here, if I'm still focused on my 4 instructions, let's see how fast that goes, how fast it gets through it. And it's 2 seconds again, so 2 cores would be 2 seconds. So it's the idea that I can process instructions simultaneously or at the same time, and if I can do that, if I do that with 2 cores or 4 cores, then I can process things much faster. I can process a program much faster just because I've got more going on at the same time. So number of cores is definitely a way we can improve a CPU as well. Finally, the last one we've got is cache size. Now this is a little bit more complicated to explain, but let's just have this quick diagram. So you imagine that I've got a CPU, and I always do CPU as a box. So there's a CPU there. I'll label that so we remember what it is later. Cache. I'm going to do that as a box as well. So cache is a form of memory, so it stores data and instructions. I'm going to put some letters in to represent that in a moment. And then here is RAM. Okay, RAM's much bigger than cache, but it has a problem which we'll come on to in a minute. All right, so cache, we've got parts of a program. I'm going to represent these as letters. It's got A and B, and then RAM's going to hold the rest of that program, so C and D, and we'll bung in letter E there as well. And before I start this, I'm going to throw some time figures out there, but they are completely made up. They're not correct for modern processors, but they just demonstrate a point. So let's say the CPU wants to get letter A. It's going to get from letter A, and let's say it takes, 1 millisecond to access cache. And so the data is returned to the CPU, and that takes 1 millisecond to access it. But then let's say the CPU needs letter C. Well, that's a problem because RAM is much slower than cache to access. So that's going to take 1,000 milliseconds to access. And it can be that order of magnitude sort of slower. So that is a big problem because your CPU has to wait around for ages to get data from RAM. So if I increase the size of cache, then I can fit more of the program into cache, and that's a faster form of memory, so the CPU won't have to wait around as much. So if I make my cache bigger here, I can put more of the program in there. So let's say I'm going to put letter C now. Letter C and D are going to go from RAM, and they're going to be moved into cache, which is that faster form of memory. And that means in this example, if I've got more cache, actually I can now get my letter C from cache, and that only takes 1 millisecond, and the CPU is not waiting around, so that's a better situation. So cache size is important because it's all about how fast that the processor can access memory. And if I have a larger cache, then on average I'm going to go to cache more often, and that's going to speed up the whole running of the program as well. So they're the 3 things that can improve your processor performance. You've got clock speed, number of cores and cache size. If you found that video useful, please hit the like button and hit subscribe to the channel. Keep learning and revising more computer science by clicking on the videos linked here.